Hey friends, Ms. Pariseau here for yet another lesson on exponential functions, but this time our focus is going to be on the percent growth and percent decay model. So yesterday not yesterday, if you were in class with me, yesterday we took a look at this, but if you refer back to the previous video, we kind of introduced this idea. And we talked about how the number inside, remember that we tend to refer to that as the rate. Okay, we saw this original form, a times b to the x. And we said how this whole value is the rate. We refer to that as the rate. Well, you're gonna see that word come up again, but it means something different in those terms. So we have to make sure that we're being clear. In this terminology, it's the rate, it's kind of the factor, like what are you multiplying by, right? Whereas now when we're talking about percent growth and percent decay, we're talking about that percentage rate. And what that means is, we talked about how in the previous video, well, if something is increasing, right? If something's increasing, you're paying the original. Like let's say an item was $5, right? And in the past, it's increased by 10% every year. Well, that means that you're paying the $5 plus 10% more. So if we, instead of finding 10% and then adding it, we can go ahead and just say, well, what is 110% or 1.1, right, as a decimal? And that's what that means, is what is the rate as a decimal? So we would take that 10% and we would change it and then we would add it to the one whole because we're increasing it. We have to pay the original plus more, right? Whereas if it was a discount, like as an idea, a decay or a discount, right? We're taking 10% off, and that means that the remaining that we have to pay is 90%. Okay, so that means this is the factor we're going to multiply by, but 10% was the rate how it decreased. Okay, so we're going to be focusing more on, when you hear me say rate, what I want you to think about is we mean the percentage as a decimal. What was the percent of growth? What was the percent of decay? Put that as a decimal, and that's what goes and fills in that R value up top, okay? So again, we also talked about, like, if I had something that looked like this, let's say this was a bank account and it's earning interest, I don't know, X, okay? Right, we talked about how the A value is our starting value, so we can see here, if, in terms of word problems, maybe they opened their account with $500, all right? The factor that I'm multiplying is by 1.2. So I can see that this is a growth because it's a number over one whole. And how much is it growing by? It's not 120%. It's, again, anything that's over the one. So this is actually a 20% growth rate. All right, so just again, getting you to understand the difference between the factor, which is 1.2, and the percent growth, which is just the difference between this number and 1, right? Same thing for decay. Like again, let's say you invested some money, but it's been decreasing by 5% each year. Well, if it's been decreasing by 5%, okay, this is what you would plug in. But when you simplify this, what it's going to look like is this. That means that the next year you have 95% of where you started. And then after that, another 95. So here, this means that the factor that we're multiplying is 0.95. But if I had to say, well, what's happening? It's a decay, and it's decreasing or decaying by 5%, all right, every year. So we need to make sure that we understand those basics as we move into these types of problems because we want to know what numbers we're going to plug in where. Okay? All right, so if we take a look at example A, the first thing we want to talk about is just what kind of model is it? Is it the growth model or is it the decay model? So as we're reading, we want to just highlight those important clues. Okay, so we've got a sealed copy of Super Mario Brothers for Nintendo sold at auction for $2,400. And this was in 1999. Since that time, okay, so this tells me this is the initial value, all right, for what it sold for. And since that time, it has increased 9% annually in value, okay? All right, so a couple things. This tells me right here that this is my A value. This right here is my growth rate. It's increasing, so I know that it's a growth model. And if I wanted to, so I can go ahead and I can write down, look at all the variables that I have here. I have A, R, Y, and T. So I'm just going to go ahead and write those ones down and fill in what I know. All right, so my A value is 2,400. My rate, okay, is 0.09. So again, I'm going to just leave it as the decimal for right now. I'll go back in and plug it into the formula right there. Okay, now my time, if I'm just writing a regular model, I would just use T, but I'm being asked to find at a specific time. So from 1999 to 2022 is what I'm looking for. Okay, all right, so this is 23 years. All right, and it wants me to know what the value is. So again, this is the output. So when I plug in all of these values here, it's going to produce this. And so that's what I'm looking for. All right, so my output is going to be the value that I get when I plug these numbers in. All right, so I'm going to go ahead and just set up everything according to the formula. 1 plus 0.09 to the 23rd. Now I can go ahead and put that right into my calculator as is. Maybe when you were filling in this number, you recognize that I could just go ahead and do this, right? I'm okay either way. I want you to understand though, that if I was giving you a multiple choice and saying, hey, which function matches this situation, that I'm not going to leave it like this. We're going to simplify it to be 1.09. So we just want to make sure that you're feeling comfortable with that format. Right? So now we're just going to go ahead and we can do that math in our calculator. Okay? And because we're dealing with money, I'm going to write exactly what happened and popped up in my calculator. 17418.8987 ... Okay? But since we're talking about money, you could round to, it doesn't tell you where to round. If you're not 100% sure, I always say go to the nearest penny. Then you sometimes, depending on the amount of money, you could go to the nearest dollar. It's really kind of based on the example, I guess you could say, like what would make sense. So that's why I think it's important to show what did we get and then what are we going to kind of approximate it to here. So for me, I'm going to go ahead and I might have done this differently in class, but I'm going to go ahead and just round it to the nearest dollar. All right, since this said $2,400, I'm sure that they're not counting pennies when they're trying to figure out those values. So I'm going to just say that it was $17,419 approximately. Okay, so pretty good for, sold for $2,400. Here's how much it should be worth now. All right, now let's take a look at example B. Okay. So here we have Le Hamster, a French artwork, was purchased by Mr. Amrine in 2014. So in 2014, all right, is when it was purchased. It's decreased 46% in value, and it's now worth this much. Okay? So here's the thing. Now it says find the purchase price in 2014. That means that we are looking for, we don't know what the initial or the A value was, but it's decreasing, so we know that it's a decay model. All right. So again, off to the side, I'm going to go ahead and write down all of the variables that are involved and plug them in. So I don't know my A value because that's going to be in 2014, and they didn't tell me that information. All right. It's decreasing by 46%, as a decimal, it's 0.46. The time, well, they're talking about now, so the current year right now is 2024. So that's been 10 years has gone by. And we now know that after 10 years, when I plug in 10, right, I get out $216.04. So do you see how we filled out all of our information? Now we can go to our formula, y equals, right, we got A1 minus R to the T. So now we're just going to fill in all of our values, 216.04, A, I'm going to go ahead and do this math right now just because it's kind of tight on space. 1 minus 0.46 is going to be 0.54, and the time is 10. Now, you have a couple of options here, and as long as you're showing your work, it's fine. You could go ahead and evaluate this and then estimate it, but the thing is it's going to be a really small number, and so basically what I'm going to do is I have to get this A by itself. So I have to divide by whatever this is equal to. So just to keep it as precise as possible, I'm going to go ahead and just divide both sides by that exponential number. So in my calculator, I'm actually going to type in 216.04 divided by 54 hundredths raised to the 10th power. And that just helps me out because, I mean, if I were to put this just value in my calculator, I end up getting 0.002108. And it kind of becomes a question of like, where should you round it to? Maybe we round to the thousands. So as long as you're putting like what you're rounding to, I guess, you know, you'd be okay with that. But we're more precise if we just keep it in that exponential power. So when I go and do that, now I have my A value all by itself. And I put this exactly how it is into the calculator, and I got 102,469, let me move that A out of the way, 0.9609 equals A. Again, I need to interpret what this means in regards to the problem. So it's talking about money and how much it's worth. Because it's a large number, I'm going to go ahead and just round my answer to the nearest dollar, okay? So I'm going to see this, that's going to go up. So it's approximately, my A value is approximately, or my starting value is $102,470 and $102,470 was the approximate price that Mr. Amrine paid for the hamster, and now it's only worth around $200. That is a big loss. That hurts. Okay? All right, so that's the idea. Again, going through determining is it a growth or a decay, what pieces of information do you know, and building your equation in that manner. Okay? So I encourage you to go ahead and work through the rest of those problems, and feel free to check in with me to check your answers, but we will have gone over them in class too. Take care.